Yeah. So anyway, I'm going to, got a few minutes before the official class time, and I wanted to mention a couple of news articles because there's a couple of exciting ones. This one is very interesting, especially for the malware analysis class. Let's see if there's some way to get past this garbage. Okay, I got to open it in a private window. There's Wired Magazine, and as you probably know, the United States and Israel, together with, I think, Germany, did the first cyber attack that destroyed physical infrastructure in the form of Stuxnet to take out nuclear isotope separators in Iran, and that was, I guess, in about 5 or 10 years ago. But there was a more recent one, which is of greater importance to me because, as you probably know, I'm going to teach an OT security class starting in a week here. And I'm doing it I'm working for a critical infrastructure company, and the Iranians hacked a water plant in Pennsylvania a little recently, and another one about a year ago that began to be in attention. But this one here, I think, brings a lot more of attention to it. And the Russians tried to attack the Saudi Aramco main oil refinery facility and destroy it, but they failed, and that was about 5 years ago. However, the Israelis did it, and it worked. They wanted to attack. See, now what's going on, of course, you probably know, the war in Ukraine is a proxy war between the United States and Russia, just like Vietnam. The United States and Russia are at war, and they don't want to admit it, so they're fighting over this country in the middle like two dogs fighting over a bone. And in Israel and Gaza is the United States having a war with Iran, and both of us trying to pretend that that's not what it is. And so Iran is behind the Gaza side, and the United States is behind the Israel side, and so the Israeli attackers are attacking Iran, which is in fact the source of what's attacking them primarily. And so the Israeli hackers wanted to hack a steel plant in Iran, and they destroyed it and burned it down, all with a cyber attack. And they have a video of it, and they explain what they did here. They're a group called Predatory Sparrow, and they claim to be moral. They claim that they attack physical infrastructure by hacking, but they're careful not to hurt anybody. And the Wired magazine's point of this article is that they are in fact very careless and nearly killed somebody, which that's true. I'm not surprised at all. This is a war. I don't think that's the interesting effect. The interesting matter to me is the technical ability of what they did. This thing is controlled. The power plant has stages of steel processing, and parts of those are controlled by OT systems, which they successfully took over and modified. And what they say, someone that knows about these plants say what they apparently did was shorten the time it takes to outgas the hot steel. Apparently the hot steel has gas trapped in it, and you have to remove the gas before you move it to the next stage or it's unsafe. And they somehow skipped that step, so that what happened is the molten steel overflowed and onto the ground, hitting the ground instead of the container, set fire to the building, and as they point out, nearly hit two people that are running away down here, running from the molten steel, like in a comic book. And that's why they say this. In Iran. So they physically destroyed and burned down an entire Iranian steel mill with a cyber attack from Israel. I know, this is a big, interesting step forward in cyber war. We've been hearing about cyber war for a long time, and of course, this should be very important to Americans because the problem has been all along, we are a target-rich environment. We have factories and banks and power plants and aircraft control towers and all that stuff, and it's all dreadfully, appallingly insecure. And they pointed out that this steel mill, for example, was running insecure stuff, and it was on Shodan with open ports. Which is true of thousands of devices, many of them in the United States, many of them under current use. And as you know, we had Colonial Oil when ransomware shut down all oil distribution for about several days on the East Coast, fouling up our system. And that was not touching the OT. All they did was infect the IT machines so they couldn't bill for the oil. In fact, this is something that perhaps didn't hit the mainstream press. They could have kept pumping the oil. They just couldn't write the bill to get money for it. But that's what stopped them dead, this being America. But the point is, now, if you're a little better at it, you can break through to the OT system and affect the physical infrastructure. And there have been cases, like there was a case in a water treatment plant about 2 years ago where they changed the amount of chlorine being put in the water to a toxic level, and if somebody noticed this and prevented it from actually taking effect. That was one of the several attacks that did not actually harm anybody. As far as we know, these haven't directly killed any Americans yet, but it's only a matter of time. And so anyway, that's why I got involved in OT security, which is very hot. How securing our critical infrastructure needs to be done, and it is not easy and not simple because the legacy systems that you have to use have no security at all, and you have to figure out how to bolt security on the outside.
What is OT?
OT is operational technology, stuff like this, steel mills, power plants, heavy industrial equipment controlled by computers, and typically the way it works is they are using unencrypted legacy protocols on proprietary software that only runs on really old versions of Windows, like Windows 98. And it was never intended to be connected to the internet at all. But now they connected all to the internet for the same reason they connect cars and light bulbs and everything to the internet, so they can remotely administer and monitor it. The advantages for the company of being connected to the internet are immense, but it introduces a new risk of cyber attacks from the internet touching the OT. And therefore, you have to have something like an OT firewall, network segmentation, VPN concentrators, and things like that from the outside. And the fundamental problem, which is what causes almost all security problems, is a human problem. The personnel in charge of maintaining the OT think like old-fashioned engineers, and they don't want any complicated encryption or anything because it'll lower the reliability. And from their point of view, safety is making sure that the devices are under direct physical control. The same thing happens in medical technology. You have implanted things like pacemakers and insulin pumps and stuff in people's bodies, and the people that design these think about safety in terms of making sure the thing can be clean and not infect you, that there's an easy way for the surgeon to put it in, and it's reliable enough to keep the patient alive. Cybersecurity is not one of those risks that's in their mind at all. They think that's ridiculous. We're trying to save this guy's life with a heart. That's their idea of safety. They already have something important they're doing and difficult with safety and security controls, and getting them to worry about some bizarre sounding science fiction-y garbage like someone coming in from the internet and hacking it is nearly impossible. And the IT people, of course, the hackers, have no appreciation for the other problems. So it's at these borders between systems where you almost always have huge security problems. One team knows what they're doing, the other team knows what they're doing, but they don't understand why the two things they're doing don't merge together well. Anyway, so I thought I'd mention this. It's a very interesting article and very important to me and the world. And that's all the news I wanted to do today.